Hi everyone, welcome back. Let's have another go at vector projection. What can we do with it? I've done two videos on scalar projection. Let's have a quick look at the scalar projection, bit of revision of what's going on. We've got two vectors here. A is 4i plus 8j, which I can write as 4, 8. This B is 8i plus 6j, which I can write as 8, 6. I picked the 8, 6 on purpose because if we go across 8 and we go up 6, there's a Pythagorean triad of 6 and 8, means the hypotenuse will be 10. So we're talking about 6, 8 becomes 10 for the hypotenuse. So that made it nice to have a look at what's going on here. Let's have a look here. So this length here is the scalar projection. How do you get the scalar projection? Previous videos we've got this A dot B on the magnitude of B. So you can put in the numbers 4, 8 and the numbers 8, 6. I prefer to write that instead of the I and the J. It's the same system, it's just written looks a little bit different. So then you'd have 4, 8s are 32, you'd have the 8, 6 are 48. The magnitude of B, we already know from Pythagoras that that's going to be 10. So it's going to be 80 on 10, which is 8. So this length here is 8. Now, let's have a look at what's going on over here. To get the vector projection, I'm saying how many unit vectors will fit into there. And of course there's going to be 8. So let's have a look at this formula for vector projection. How many scalar projections would there be of the unit vector? How many scalar projections, or how many unit vectors will fit into the scalar projection? So this is going to be obviously 8 of those. There's a unit vector in that direction there. If you look at it, there's a unit, so there's a unit vector there. And if you count across 1, 2, 3, 4, 5, 6, 7, there's 8 of them, even rough doing it like that. So let's have a look at our formula. We know that the scalar projection is going to be 8. We're going to get 8 of what? 8 of the unit vector. Which unit vector? The vectors in the direction of B. So I want this red vector, and I say how many of the black vectors would there be to get that red vector? Let's have a look what it is. We know it's 8 of the unit vector. So how long is the unit vector? The unit vector is the B vector divided by its magnitude. So let's have a look at that. The B vector, if we divide it by 10, because it's 10 units long, if we divide that by 10 we get a unit vector. So if this one here is an 8, the vector B is 8, 6, and the length of it is 10. So we're dividing that vector into 10, and there it is there. Dividing that vector into 10, so making it back to the length of 1 unit. So here we've got 8/10 of, and I'm going to write it the other way for a moment, of 8i plus 6j. So what can we do with 8/10? You can write it as 0.8 if you wanted to, 0.8 of 8i plus 6j. Could have done it leaving it in the other form, but decided to go back to i's and j's. Okay, so what have we got? 0.8 by 8 will be 64 with 1 decimal place, 6.4i. 6 8s are 48 with 1 decimal place, so that's 4.8j. So this vector we've got here, the vector projection of A onto B, this red vector here, is now this one here. So let's have a quick look at it rough. 1, 2, 3, 4, 5, 6, and 0.4 is about there. So there's the 6.4i plus the 4.8j. 1, 2, 3, 4, 4.8i, 4.8j. So we've gone across 6.4, we've gone up 4.8. That's that red vector there. So how do we get it? It's the A dot B on the magnitude of B, which is the scalar projector, times by that number of the unit vector in the direction of B. So a unit vector in the direction of B. Now if I took it again and say we don't look at all that understanding, and we look at it as a rule, a lot of people prefer to write this as A dot B on the magnitude of B, times by B on the magnitude of B, and they can remember it as a formula that way. There's another way to remember it as well. This is A, and by the way this is B unit vector, and that's another B unit vector. So your vector projection is starting at A, you're projecting it onto B, and the weird thing is it turns out to be multiplied by the unit vector B by the unit vector B. So one of the annoying things about this topic is there's so many ways to think about it. I'm still, as a teacher, thinking which way do I prefer to teach it. I do still think of this. I think it's better, well what I'm seeing when I mark people, I keep thinking it's better for people to really understand what's going on there. So it's the scalar projection times the unit vector B. So it's the scalar projection times the unit vector b. So you're saying how many of those will fit into there.